Good day, everyone. This is Professor Friday coming at you one more time. Today we are discussing graphs of functions with particular limits. So the problem we're going to take a look at today is going to be sketch the graph of a function with the following aspects. Limit as x approaches 0 from the left of f of x is equal to 2. Limit as x approaches 0 from the right of f of x is equal to 0. Limit as x approaches 4 from the left of f of x is equal to 3. Limit as x approaches 4 from the right of f of x is equal to 0. F of 0 is 2, and f of 4 is 1. So, those things in mind, since we're sketching the graph of a function, first thing I want to do is create a set of axes, something like this. And what I'm interested in doing is breaking down each of these one-sided limits one piece at a time. So, I'm going to switch things up, switch it over to a red pen so as to actually interpret some of these things. So first thing that we have is this limit right here. The interpretation of the limit as x approaches 0 from the left of f of x is equal to 2. This lets me know that as x gets really close to 0, y is getting really close to 2. The concept of a limit, though, is that it's not necessarily actually hitting that value. Now, the other important thing is the from the left portion, which means specifically that x is going to be less than 0. Now, what that means in the context of a graph is, as x is getting really close to 0, we're going to see that y is getting really close to a value of 2. Now, what that means in context is that it looks like it's going to be getting really close to, but not necessarily touching. Now, on a graph, we can symbolize that most easily by making use of the open circle. Now, this is also exclusively from x is less than 0, or from the left side, so I'm going to indicate that it's only on the left side that the function would be approaching this value. Whereas this guy right here gives us an additional piece of information, which is that x goes to 0 from the right, y is going to approach 0. Now, again, this is a one-sided limit, so it indicates that it only approaches from one side, specifically when x is greater than 0. So, once again, we'll signify that with an open circle to let us know that we're not necessarily going to be actually hitting that value, but we'll throw the open circle on there anyway. Now, if we wanted to include a closed circle in here, we would need to know the actual value of f of 0. Thankfully, that information has been provided for us. F of 0 is equal to 2, indicates an ordered pair on the graph being at 0, 2, and that'll be a nice solid dot. Now, I noticed that we were previously using the ordered pair 0, 2 as an open circle. What that means is that independent of the limit, we can go ahead and fill in that circle right there. So, that's all of the exciting stuff going on at x equals 0. We also have a couple of exciting things going on at x equals 4, a couple of one-sided limits as well as the definition of the function. So once again, we'll try to break this down one piece at a time. This part right here, limit as x approaches 4 from the left-hand side of f of x is equal to 3, means that x approaches 4, y is going to approach 3. Approach, but not necessarily touch. So once again, we'll be using an open circle for this. However, because it is a one-sided limit, that also lets us know that x is going to be less than 4. So, go ahead and indicate y value of 1, 2, 3. What we'll see, because this is a limit, is a nice open circle at the ordered pair for 3. Now, this is only coming from the left, so what I'm going to do is indicate that only from the left will we be approaching that open circle. Additionally, we also have this piece of information over here. Wow, we're starting to get cluttered, my goodness. That as x approaches 4 from the right-hand side, y is going to be approaching a value of 0. Not necessarily hitting, so once again, we're going to be using an open circle for this concept. Now, this is only on the right side of x equals 4 because we're approaching from the right, so that'll be greater than 4. So once again, open circle, and we'll indicate that it goes off to the right from that point. So to reiterate, for a limit approaching from the left, that means that from this point we would only be going to the left. That way on the function we can approach that value from the left. Whereas down here we can approach this open circle from the right if we approach it from the right. Same thing goes for x equals 4. Now, those things in mind, we also have that f of 4 is equal to 1, which lets me know that there's going to be a closed circle at the ordered pair 4, 1. Now, unlike what was going on at x equals 0, this indicates to us that we have no open circle to fill in here. Now, one of the important things about this being open and this being open with this being closed is we need to make sure that it passes the vertical line test. So we draw in a vertical line, it passes through the open circles and hits the closed circle once, it's still a function. Now, outside of that, it's simply a matter of connecting all the pieces that we have together. So we can indicate that this one just kind of goes off in whatever direction to the left. Going from x equals 0 to x equals 4, though, we have two sides that we can... Excuse me. Dusty down here. We can connect these two pieces together, like so. That way we can approach 4 from the left and 0 from the right using the same piece of the function. Finally, this portion, it doesn't really matter the direction it goes off as long as it continues over to the right. So please know that there is a little bit of creative control in your answers here. This piece that goes off to the left doesn't have to go down or up. It can go wherever as long as it's going left. In between, we're connecting these two open circles together to maintain the one-sided limits 0 from the right as well as 4 from the left. Finally, this portion of the graph doesn't necessarily have to go down, doesn't necessarily have to go up, as long as it goes off to the right. Finally, we want to make sure that this thing obeys the vertical line test, so at no point in here should a vertical line intersect with the graph more than one time. So that's why we don't want to see pieces of graph above each other on the graph. I hope this was informative. I hope you took something from this. Have a great day, and I'll see you for the next one.